Welcome, Province Stats. Mr. Monahan bringing you the Quiz A answers. This is the Chapter 2 review. You should have taken this quiz in Schoology already. Feel free to fast forward to just the questions that you need to look at the correct solution for. Question 1. A bag contains 6 red marbles, 7 white marbles, and 6 blue marbles. Find the probability that we get a white. Nothing too tricky here. We would want to make sure that we get a total of these 3 numbers. We know that there's 19 marbles in the bag. We're just picking 1 white marble out. That is our answer. Doesn't simplify at all. 7 out of 19. We'll make it a little bit trickier. If we have a little bit of a different problem where we're doing an or, same amount of marbles, 6 red, 7 white, 6 blue, so still 12. We want the probability that we get either a red or a blue. So probability of red or blue, that'll be the probability of red plus the probability of blue. And then when you do adding problems, you want to make sure that you don't have any overlap. This one doesn't have overlap because you can't get a marble that is red and blue at the same time. So we have the amount of red, which is 6 over 19, plus the amount of blue, which is also 6 over 19, for a total of 12 over 19. That doesn't simplify either, so for the answers on my screen, it would be option B. If you look at option A, that one's impossible because it's more than 100%. And letter D isn't going to really be possible either, since 19 is prime. We're not going to be able to get to 2/3. So sometimes with multiple choice, you can eliminate some options. A bag contains 6 red marbles, 7 white marbles, and 6 blues. So we're still at 19. The squiggle means not. So this says the probability we get something that is not white. So that would be the only other marble, all the marbles except for the white marbles. So that's going to be 12 again, because there's 6 blue and there's 6 red, a total of 12 out of 19. So we did basically the same exact problem twice in a row. Red or blue is the same as not white. Question 4, they're changing the number of marbles on us now, so be careful with that. But we have a total of 18 now. The probability that we get red and blue, we're only picking, sorry about the bad handwriting, we're only picking 1 marble. There's 18 to pick from this time, but it's going to be impossible to pick a red and a blue at the same time. 0 out of 18, which is 0. You can't pick 1 and have it be 2 different colors. So we say that's a 0% chance. All right, number 5. Tisha is in the French club. There are 9 students in the club. 7 are girls, which means there's 2 boys. Let's write that down right away. The French teacher will choose a group of 3 students to guide visiting students from France. What is the probability that the group has 3 girls? Okay. So there are 3 girls total. So the probability that we'll have 3 girls, all right, is going to be equal to the probability that we have 3 girls, or the number of groups that have 3 girls, so 3 girl groups, divided by the number of 3-person groups, the number that are possible. All right, and the way we do this is with combinations. So the amount of 3 girl groups would be the number of girls and the number of girls we want, which is 3. Technically, you got to think about how many boys would be in this group, which will help us with question 6. There's only 2 boys, and we're going to choose 0 of them. That really doesn't do much to our math, because 3 girls really has also 0 boys. Okay. On the bottom, we have a total of 9 people to choose from, and we're choosing 3. So 9 choose 3 gives us the amount of 3-person groups that are possible. So what we want to do with these is get these punched in. 9 choose 3 is 84. 7 choose 3 is 35. The 2 choose 0 doesn't do anything. That's just 1. So we have 35 divided by 84. Then I notice that we have decimals for my possible answers over here. If I type in 35 over 84, I get 0.41 and then a bunch of sixes in a row. So, sorry about that. So that would round to 0.417, which is letter C. Okay. Same setup for this problem, but now we want the probability that we have 2 girls, 1 boy. Okay, well, on the bottom it's going to be 9, choose 3 again. On the top, there's still 7 girls, but now I want to choose 2. And there's 2 boys, I want to choose 1. So the bottom is still going to be 84. The top is 7, choose 2 times 2, choose 1. So when you type that in, you can do them separately, or you can do it all in one step. Just be careful how you type it in. There should be 42 groups that have 2 girls and 1 boy. That simplifies to 1/2, which is 50%. Option C. Question 7, Joey's sock drawer is unorganized. It contains 2 black dress socks, 7 black ankle socks, 5 brown dress socks, and 5 brown ankle socks. What is the probability that Joey will blindly reach into his sock drawer and pull out a sock that is brown or a dress sock? So probability of brown or dress sock, that would be probability of brown plus the probability that it's a dress sock minus the probability that it's both, which can happen because some of the brown socks are dress socks. So there's going to be some that are both. One thing I should have done right away is get a total. There's 19. If you add up 2, 7, 5, and 5, that's 19 total. So out of 19, it says that there are 5 and 5, so 10 brown socks, 5 dress socks, 5 ankle socks, plus the amount of dress socks out of 19 would be, there's 2 black dress socks, there's 5 brown dress socks, so 7 out of 19 that are dress socks, minus the probability of getting a brown dress sock, that's 5. So that's 17 minus 5, or 12 out of 19, which is already simplified. They want fractions, so I'm not going to type it in and get a decimal. Question 8, in a 5-question true or false quiz, what is the probability that true is the correct answer for all 5 questions? This is probability of true, 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 true. Okay. There's a couple ways you could think about this. There's only one correct answer key. Okay. There's only one way for it to be true, 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 true. Okay. We got to think about the number of ways that this answer key could work out. So what I'm talking about there is there's 5 questions that each have 2 options. So I'm going to write that as 2 to the 5th. There's 2 options for each problem, either true or false. So to count up the amount of answer keys, it would be 2 times 2 times 2 times 2 times 2. So that is going to give us 32. So this is 1 over 32. Another way you could have thought about it is the probability of tails 5 times in a row. Or I'm sorry, probability of true 5 times in a row. All right, but each one of these will be 1/2. So 1/2 times 1/2 times 1/2, 5 times in a row, which is still 1 out of 32. There's a couple ways you can do that problem. The answer is 1 out of 32. Question 9. This is a spinner used in a board game. What is the probability the spinner will land on a multiple of 3 and 4? Okay, so let's find, there's 8, so the probability that we land on a multiple of 3 and 4. That's not a multiplying and, it's just, it's both a multiple of 3 and 4. Out of 8, we have to think of how many, 8, right? Yep, there's 8 spaces on the spinner. We need to know how many of them are a multiple of 3 and 4. So let's start looking through them. The number 12, 3 and 4 both go into that. Okay. The number 10, neither go into it. 18, 3 goes into it, but 4 does not. 36 is a multiple of 3 and 4. 54 is a multiple of 3, but it is not a multiple of 4. So that one doesn't work. Let's see, 22 is not a multiple of either. 24 does work. 64 is a multiple of 4, but not a multiple of 3. So there's 3 ways to do this out of 8, and that's going to be our answer. So multiples of 3 would be 12, 36, and 24 in this problem. All right, this one says you have to pay $9 for each spin on the spinner shown. If the spinner lands on the 3 or the 7, you get back $24. If the spinner lands on the 2 or the 6, you get back $12. If it lands on anything else, you lose. You're out the $9 and don't win anything. So the expected value of this game, remember how that works. We have kind of the amount that you would win, or the prize, and the probability that you win that prize. We make a table out of it. Okay? In this problem, we could either win $24 or $12. Or you could win $0, which is something that we can get to. All right, so what we do with these, the probability that we win 24, okay? This is another spinner that has 8 options. So the way that you win 24 is if you land on the 3 or the 7. So there's 2 ways to win out of 8. This is 0.25. Okay? Let's look at the ways to win 12. If the spinner lands on the 2 or the 6, you get back 12. The 2 or the 6, you get back 12. That's still 2 ways to win out of 8, 0.25. So then if you land on anything else, there's 4 options left, 4 spaces left. Out of 8, there's a 0.5 chance that you don't win anything. All right? So to get the expected value, we need to multiply down and then add across. So the expected value of this one is $24 times the probability that we get $24, plus $12 times the probability that we get $12, plus $0 times the probability that we get $0. Okay, so that, let's see, we have 24 times 0.25, that would give me $6 even. $12 times 0.25 gives me $3 even. 0 times anything gives me 0. So this has a total of $9. That's the expected value. That's the answer to this first question. Okay. The question is whether or not it's a fair game. Well, that you have to look at how much you have to pay. This says you have to pay $9 for each spin. That matches our expected value. These 2 things are the same amount, which means, yes, this is a fair game. The only way that it's a fair game is if the expected value matches the cost to play. And our last one on this one is, let's see, there's 500 raffle tickets that are sold at a cost of $1 per ticket. There will be 1 $100, $5 $50, and 10 $20 winners. What is the expected value of someone who purchases 1 ticket? So let's start our table. Prize, probability of winning that prize. We can win $100, $50, $20, or $0. Let's start finding the probability of these. It's always going to be something over 500. That's how many tickets were sold. There's only going to be 1 $500 winner, or one $100 winner. So there's a 1 out of 500 chance that we win 100. There's a 5 out of 500 chance that we win 50, which simplifies to 1 out of 100. There will be 10 $20 winners out of 500, which simplifies to 1 over 50. 1 in 50 chance. The rest of them is going to be a 0% chance. So there's 16 winners. There's 16 winners, which means there's 484 ways to lose. I'm not going to simplify that one because I'm going to multiply it by 0 in a second. Okay, so the expected value is $100 times the probability of winning $100 plus $50 times the probability of winning $50 plus $20 times the probability of winning $20. So for this one, we have 100 times 1 over 500. That's like just 100 divided by 500. That's $0.20. 50 times 100 is $0.50. 20 times 1 over 50 is like 20 divided by 50, 40 cents. So it looks like we have 90 plus 20. So we have the expected value is $1.10 for this game. Okay. Let's see if it asked. Yeah, so the expected value of someone who purchases a ticket, that's how much they would potentially win. But you have to think about the cost to play. So if you're asking if this is a fair game, 110 minus 1, that leaves us with $0.10. And that would be how much you expect to gain by doing the raffle each time. So the expected value is actually, it's not a fair game, but it's actually in your benefit. You would kind of win 10 cents more than you would have to put in. So I really shouldn't have circled the 110. The 110 was part of the answer, or I needed it. I needed the 110 to get the answer. But I have to remember to subtract the $1, which is the cost to play. So the answer that goes into the Schoology page is 10 cents. If they give you the amount of money it costs to play, that number has to go in there. And that's our first quiz. So feel free to rewatch and retry that quiz as many times as you need.